Yeah, we're going to simplify this one using only positive exponents, no problem. Now for this one, once again, just kind of like we're used to with equations, even though this is an expression, which isn't a problem. But I would look at this just as a numerator and denominator separately, because they are in two separate sets of parentheses, and I would say, look, I got my exponent right here, this -1. Well, I'm going to distribute that -1 into each of the exponents, and yeah, that 3 has an exponent of 1, just like we saw in that last example. And since I'm distributing it into the inside of the parentheses, I'm multiplying these exponents, okay? So the base 3 is now going to have an exponent of 1. 5 times -1 is -5. That's our exponent for x. And -1 times -1, the exponent of y, now is +1. But the bases stay the same. That's why I'm kind of writing this out in a different order just to show that we can, all right? So the bases are the same, 3x and y, but the exponents change based on the distribution of that -1. Well, that's just the numerator, but we've got to distribute the -4 exponent into these other exponents in the denominator right there. So 4 times 3 there for each of them is going to be -12. And the bases stay the same, x, y, and z. So now that we have this set up, we've taken away the distribution, so we can look at this hopefully a little bit more clearly at this point. And there's a couple ways you can go about it at this point. If you wanted to start reciprocating some of the values to make the exponents positive, you can. Or if you want to go straight into the exponent rules with division, which would be subtracting the exponents of the same bases, you could. I guess personally what I would probably do at this point is flip some of these that have the negative exponents. So here's what I mean by that, okay? So anything with a negative exponent, there are a lot of these values that have negative exponents. I'm going to start flipping them, okay? So for example, the 3 to the power of -1, I want it to be a positive exponent, so I'm going to flip it into the denominator and show it now as 3 to the power of 1, because once it crosses that fraction line, it changes the sign of the exponent. And I can just write that as just a regular 3 right there like that. And I can go through all the terms, so the x to the power of -5 as well. I'm going to flip it now into the denominator so that it becomes x to the power of 5, like this. The y to the power of 1, it's just going to stay, and I'm just going to show it as y. Well, you can show it with the power of 1 if you'd like, though. Okay, so that takes care of all three terms in the numerator. Now I'm looking at the denominator, these three terms with the -12 exponent, so all three of those are going to flip into the numerator. So yeah, that x to the power of -12 is now in the numerator, but it's a positive exponent. Y to the power of -12 in the denominator is now y to the power of +12 in the numerator. And z to the power of -12 in the denominator is now z to the power of 12 in the numerator. So now I've rewritten this, but it has no negative exponents, which is, I don't know, again, for me, I think it's a little bit easier to work. But you didn't have to do it like this, right? You could have jumped straight into the exponent rules, which is what I'm going to do now. So I'm looking at each of these values, and the 3, there's nothing really to do with it, or the z, right? Or there's no other like bases to combine with it. So I'd be looking specifically at, let's start with, I guess, the x's, okay? Now we got an x to the power of 12 in the numerator, and x to the power of 5 in the denominator, so since it's numerator and denominator, or that it's a fraction, alright, yeah, and that was z to the power of 12 there. So x to the power of 12 minus 5 is what we end up with, and that's going to be x to the power of 7. I'll make that the same color there. X to the power of 7, okay? Now, since it's a positive exponent now, after we've subtracted those two exponents, I'm going to keep that in the numerator. And again, another way to look at this, we went over this in the lesson, there's 12 in the numerator, 5 in the denominator. So we know that after we operate with the exponents, there's whatever's left over should be in the numerator as well. Now, the y values are both in the numerator already, so whatever we get is going to stay in the numerator. So that's y. But since both of them are in the numerator and we're multiplying in the numerator, we're going to take those two exponents and add them together. So that's y to the power of 13, 12 plus 1. So there's our 13, and I'll just kind of clean this up a little bit. We got this fraction. I'll put the 3 more in the middle, for example, and then kind of clarify on these. Y to the power of 13, x to the power of 7, z to the power of 12. See, I did it again there at the 13. There we go. All right, and that's our answer.